Okay, working on section 5, chapter 2. This is day 2. And today we are going to focus on kind of working with these trig functions and how does that change the picture for implicit differentiation. And then I think this will become a day 3 for us, where we find the normal equations. Normal equations. All right, so yesterday we learned a little bit about doing implicit differentiation when we had the dependent variable and independent variable intermixed. So on this side on the right side of the equation, we can see that we have x and y's intermixed there. So we'll just go ahead and take the derivative, and the derivative on the left will be a 2 dy dx. You got used to that pattern when it is the dependent variable and we're taking it with respect to a different variable, which is x. We must write down the derivative of y with respect to x. This next term will be simply 2x plus the derivative of sine becomes cosine. I leave my inside function, which is y alone. And now I chain rule off the derivative of the inside function. The derivative of y is dy dx, and that's held together with multiplication. Just like before, we're going to isolate the dy dx terms. So to do that, I'm going to bring them over to the left side. So this cosine y dy dx is going to come over to the left. I'm going to have 2 dy dx minus cosine of y dy dx is equal to 2x. Followed up by, I want to solve for dy dx, so the best way to do that is to GCF dy dx. So I'm going to pull out dy dx from both of these two terms, bring them forward, and what gets left behind is this 2 as well as the minus cosine of y. And that's equal to 2x. Now the next step is you want to solve for dy dx. And we can solve for dy dx simply through division. Since I have multiplication holding those two together, we're going to divide and get dy dx is equal to 2x over 2 minus cosine y. Can I cancel or divide by 2? No, not really. Because of the minus sign in between here, I cannot simply just cancel the 2's. There's our answer. Next one, I've got cosine of an inside function, and boom, there is two things multiplied. Yeah, that's going to be a product rule, isn't it? So let's work with like a chain rule idea. We take the derivative of the outer function first. Derivative of cosine will switch to negative sine, and we leave the inside function alone. Multiply, chain off with the derivative of the inside. So now I'm into product rule, right? Product rule, derivative of the first. So this is going to be by multiplying, and I'm going to have derivative of the first, which is 1, times the second, plus derivative of the second is a dy dx, multiplied by the first, which is x. I'm going to throw that in front. On the right side of my equation, the derivative of 1 becomes 0. Now, isolating the term with dy dx, a little bit tricky because we've got this multiplying. And you know what? If I'm divided by negative sine x, y, don't do this because you're going to see why in a minute. I essentially lose track of it, don't I? Because this side would still show up as 0. That seems like I could be missing something. So I think that's a risky move, and I should avoid it. So how else? Well, one thing I could do is I could distribute this and create two solid terms here. And indeed, that's what we're going to do. So we're going to multiply negative sine times this y, and I'll have negative y sine of xy minus, because then this negative sign is going to minus here, negative x sine of xy multiplied by dy dx equals 0. That was simply a distributive step, so we distributed. Now let's isolate. Isolate our dy dx terms. So since this is subtraction, we're going to add it to the other side. So I'll have on the left, it's going to leave me negative x sine of x y dy dx, and that's going to equal, we'll plus this over, we're going to get y sine of xy. Solve for dy dx. To solve for dy dx, I am going to divide by negative sine xy, right? Negative sine of xy and negative sine of xy. Leaves me dy dx. And, oh, look at there. Did I lose? Oh, I lost my x here. Sine xy will cancel with sine xy, right? And our final answer is going to have a negative, which I'm going to let float to the top. And I'll have y over x. So we get a negative answer. We can write it at the top, the bottom, or the middle. I'm going to choose the top. This next one has a lot of terms and it looks a little confusing, much like the plays that go on in a basketball game. So perhaps what I want to do is make a game plan. I think I'm going to take the derivative of each term, and I see a product rule. Be aware of the product rule, right? With that 6x squared y. And then I just want to solve for dy dx. Oops, I wrote that backwards. Dy dx. And then it says find any points where the horizontal line is, or the tangent line is horizontal. Oh, then that means I want dy dx to equal 0. Where does that happen, right? That's kind of my game plan. All right, so let's do this work. The derivative of this will be 6y squared dy dx. We got that by taking 3, moving it down. 3 times 2 is 6. Reduce the power by 1 gives me a squaring. And then since y is a dependent variable, it's going to be a dy dx. This here will generate product rule, and I'm going to group it such that I have 6x squared as one of my groupings and y as my other grouping. So this will be product rule happening here. So plus sign because of the plus sign there. 6x squared, that'll be a 12x y, derivative of the first times the second, plus derivative of the second times the first. My first I'll write down as 6x squared, and now I get to take the derivative of y, which is dy dx. Minus derivative of the next term, that's a nice easy one, 24x, plus derivative of the 6y becomes 6 dy dx. All equals 0. Hey, not bad. But what I do see, this is different than what we've had before. What I do see, I don't like crayon, I want a highlighter. What I see is I have 3 terms now with dy dx in it. That's okay. We can handle that. Let's keep those terms on the left side and move the others to the right side. So you know what? I'm going to move those others over. So I'd add the 24x, sending it to the left, and let's send this one to the left by subtraction. That leaves me, I'm going to just erase this so you can see what I'm left with. And I'll take care of that. That leaves me those 3 terms. They all have a dy dx in common, so I'm going to factor out my dy dx at the same time that I write these down. So I'm going to have a 6y squared plus a 6x squared plus a 6. And now solve for dy dx. Dy dx is going to equal, these have a 6 in common, so I'm going to have 6, oh, they also have an x in common, 6x times 4 minus 2y. Check it out. Does that equal 24x? Yep. And 6x minus 2y equals the 12xy. I'm going to divide by this, but what I notice as I'm dividing, they have a 6 in common, so I'm going to factor out that 6 while I'm doing this. I did a couple steps at once. Hopefully you can follow. Well, what does that give me? What does it give me? Well, the 6's are going to cancel, aren't they? And that's going to give me a dy dx is equal to x and 4 minus 2y over y squared plus x squared plus 1. And the overall question of the overall problem was like, where's the tangent line horizontal? Well, where is the tangent line horizontal? Well, it'd be where the slope is 0. So that would be where dy dx equals 0. So I could take my derivative and set it equal to 0, but really the only thing that can go to 0 is the top, right? If I had the bottom 0, that would be division by 0, which would produce, who knows what. It's an undefined function dividing by 0. So I could have just the top really set equal to 0 so that I can find out where this occurs. I have two factors. Either x is equal to 0 or 4 minus 2y is equal to 0. That means 4 is equal to 2y, which means y is equal to 2. I have two locations. It's either when x is 0 or when y is 2. And we could go find the ordered pairs by going back to the original function. All right, I think that's probably enough for today. And so I'm going to skip over this. Your homework, what I would like you to do is get this started by approaching these first 4 problems using implicit differentiation. You can see you have some trig functions present. I foresee you using product rule, don't you? Got 2 things multiplied. Product rule there. Little chain rule on a number 11. And here we've got chain rule with a product rule sitting inside. You got x times y. So, all right, good luck.